Good morning, everyone. Good morning from Norway, at least. We are gathered here, and it's a good day in the spring. We're actually seeing the snow disappearing and the sun coming up quite nicely here in Norway. So for us, it's a happy good morning. I hope it's for everyone here on the call. So welcome to this webinar on wireless M-Bus. We will go through a few housekeeping items before we get started here. First of all, if you're on the call, please introduce yourself in the chat window, who you are and where you're from, to give us an idea on the spread and the participants here today. Presenting today will be Peder Martin Evjen, the CEO of Radiocraft. He will get the word here in a minute or so. I am Anders Olderbeck, Sales and Marketing Director of Radiocrafts, and also on the running the show, controlling the chat window, etc., is Nelius Sukauskas, he's working as the marketing and sales responsible for digital marketing, etc. A few housekeeping items before we get started. We plan this seminar for 30 minutes. After the seminar is done, we will have a Q&A session. Please post your questions in the chat window in real time. We will take note, and after the show or after the actual presentation, we will take time to respond to them. We will respond to as much as we can in live on audio, but if there are anything remaining, we will then take a note of that and make sure that we respond to that either in the chat window or on the one-on-one over email or so. We will record this webinar. So for anyone who didn't get the whole thing, or if you have colleagues who wants to see this, please just refer them to our website. It will be up on the website in a week or a couple of days. Also, at the end of the show, we will make an offer for the development kits. So stay tuned for that one. We'll talk more about that at the end of the webinar. So this presentation today, it will give you an understanding on what wireless M-Bus is. It is, as I think most of you know, established standard in the metering world, but it's also good for many applications outside of the metering world and also the large metering companies. So what we believe is that the first step is to understand it, and then obviously second then is to understand the advantages and disadvantages of wireless M-Bus. And this is what the core of the webinar will be centered around today. We as Radiocraft, we've been involved in many of the standards group and committees for wireless M-Bus and the OMS. So we believe we have a very, very good insight in terms of what are the benefits of wireless M-Bus, but also some of the trips. Some of the bad sides that also you need to be aware of. Wireless M-Bus is good, but it's obviously not good for everything, also in the wireless world. So with that, this seminar will give you all the answers, we hope, and be of use for you whenever evaluating wireless M-Bus now and also in the future. So with that, I leave the word to my supervisor, Mr. Peder Martin Evjen. Peder, the floor is yours.
Yeah, thank you, Anders, for the introduction, and good morning, and welcome to everybody to this webinar on wireless M-Bus. So we are here to help our clients to make successful developments, and today we will help you to understand the basics of wireless M-Bus, how to choose the right frequency band, and also to choose among the different modes that wireless M-Bus provides. And there's also a lot of different security mechanisms you should know about. So we will look into these different modes in some more detail, and also the dialects of wireless M-Bus, how it is used, for example, in Italy and in France. We will have a look at some of the advantages and disadvantages of the wireless M-Bus protocol. And I will also give you an update on the evolution of the standard. There is some ongoing work right now in the standardization group and also developments in OMS. And I will give you a short introduction to the WISE Alliance. So first of all, wireless MBUS, that's an international standard known as the EN 13757-4. The current issue is from 2013, but as I mentioned, it's an ongoing work to upgrade it, and it should be released later this year. And it's also the only wireless standard in Europe that was developed specifically for meter reading. It operates in the license-free bands at 169 megahertz, 433 and 868. We will get back to that. Today there are tens of millions of meters already deployed using wireless MBUS. So it's really a field-proven solution. It's ideal for low-power battery operation. So it means it was developed for gas meters, water meters, and heat meters. But of course, it's not limited to that. It's using license-free bands, so it can also be used for any type of industrial sensor applications, like we know as the low-power wide area networks, and then not only for metering applications. To put it in a context, the wireless MBUS is a part of the MBUS standard series, which now consists of 7 parts and also a technical report. And several of these are under revision right now. What we will do today is to look more into the part 4, which is the real wireless MBUS part with the physical layers and the link layers. But also we will have a look on the part 7. Part 7 is actually new this year because the old part 3 was split in 2. It's simply grown and a bit too large as a document. And the part 7 contains transport and security services, and also defines the different security modes. So we will look a little bit into that. That being said, it's also interesting to note the part 3, which is the application layer of MBUS. So that's the application layer running on top of the wireless MBUS, or even the wired version described in part 2. Okay, as Anders mentioned, Radiocrafts is heavily involved in this standardization work. We are representing Norway in the CEN TC294. That's the technical committee in charge of the standard series. And we are also taking part as technical experts in the working groups, so the VG4 and the VG5, working on these specific documents. Radiocrafts is also a member of the OMS, the Open Metering System, which was a German initiative, taking part in the working group 1 there. We did some contributions to the SHIG in Italy, which is now using wireless MBUS at 169 megahertz for the gas meter deployments in Italy. And finally, we are a member of the WISE Alliance. That's a French initiative, also using wireless MBUS 169 megahertz. And I will get back to you with a little bit more details on that. So, about the ongoing updates of the standard. First of all, we have the part 3 and the part 7, and also the technical report. So the main new thing here are the security methods. So there are new methods specified for encryption, and also authentication has been added, and some key derivation functions. So this now makes up like a new toolbox you can use to improve the security of the communication. I'll also get back to that. For the part 4, That's the core wireless M-bus. There is an update on the physical layer for the 169 megahertz. We are adding some new radio channels and also adding a new data rate. So this should make it more flexible. Another addition is forward error correction that is used to support more reliable firmware download over the air. So when you have large amount of data to be downloaded, it could be firmware, but it could also be other types of data, then forward error correction is used to improve the quality so you can avoid repetitions, etc. And that's now standardized in the new version of the Dash 4. So the inquiry process is ongoing now, and we expect the release of the document by the end of this year. So where to get these standard documents? Well, unfortunately, they are not for free, so you cannot just search them up on the web, but you can contact your local standardization body. That would be like the BSI in Britain or the DIN in Germany, etc. And you should then find it on an online web shop. So yeah, there is a small fee to get them, and this is just to support the standardization work. So the standardization work is done for free by all the participating members. So just to remind you, the standard was made for metering, but it's definitely not limited to metering. So it's also very useful for any type of wireless sensor networks in general. So although my discussion will refer to metering, keep in mind that also any similar sensor network can take the benefit of the standard. So let's take a closer look into the standard and the different layers, starting at the bottom with the physical layers, describing the frequency bands and the different modes. So wireless M-bus is operating on 3 different frequency bands: 868 megahertz, that was the original one, and then 433 and 169 was also added. Within 868 megahertz, we have different modes known as the S mode, the T mode, and the C mode, and even an R2 mode. I highlighted here the T mode and the C mode because these are the modes most frequently used. And you can also see some of the specifics with the data rates and the coding and the actual throughput. So for T mode, you will have an effective throughput of 67 kilobits per second, while the C mode is made a bit more efficient using the NRC coding to get 100 kilobits over the air. In addition to the modes, there are also different frame formats. We refer to them as the frame format A and frame format B, and the B was made to be more compact. And you can then combine the frame format B together with mode C and also with mode N. Yeah, so the R2 mode I will not talk about. It's very rarely used. Also on 433 megahertz, where we have the F mode, it's also quite rarely used. However, the 169 megahertz is growing in popularity. It is the narrowband mode. It offers 3 or 4 different data rates, from 2.4 kilobits per second up to 19.2 kilobits per second. And by narrowband, we mean it operates in 12.5 kilohertz channels. And this is why it gives us very good sensitivity. Of course, the data rate is limited, but as we have seen, this is usually enough for metering data, which normally is just a few bytes or few tens of bytes. In order to operate outside Europe, because the standard is really a European norm, the OMS group have defined how to use the S mode and the T mode also in other frequency bands. So we have ported the S and the T mode to 433 megahertz and also to 865 and 868 megahertz, a special subband at 868. So in a minute I will show you an overview of that. Just to mention that there are also some proprietary solutions made for 915 and 921 megahertz, and this is to be able to operate in the US. But so far, this has not been a part of any standard. Okay, so within OMS, we added some frequency bands to be able to operate outside Europe. And here you can see an overview of that. In the top, you can see a table where we have the physical layer A, which is the one used in Europe. And second, we have the physical layer B, operating on 433 megahertz. So this is intended for countries like you can use it in South America, for example, in the Middle East, etc. Then we have the physical layer D. It's still in the 868 megahertz band, but it's limited to using one subband only. So that's why S and T mode actually use the same frequency. And next we have the physical layer E, which is intended for India, operating on 865 megahertz. Okay, so I'll leave it to you to study the details of this, just to let you know that there exist possibilities for using wireless M-Bus also outside Europe. Okay, so what are the typical characteristics of the modes? Well, the S mode was made for what is referred to as a stationary readout. It has a fairly low data rate, so transmissions should not be, say, too frequent. While the T mode, using a higher data rate, or a chip rate of 100 kilobits, is made for more frequent transmissions, because the transmissions are shorter and therefore reducing the current consumption. Then the C mode was introduced as a compact mode, taking advantage of new chipsets that support NRC coding. By using NRC coding, one chip is actually the same as one bit. So the data rate over the air is actually 100 kilobits for mode C. So it's very useful for frequent transmissions, even drive-by solutions, where you might have transmissions every few seconds. Yeah, from 10 seconds to every 20 seconds is actually typical. Still having a very long battery lifetime. And by long battery lifetime, we mean years, 5 years, 10 years, even 15 years. Then we have the N mode, that is the narrowband mode. It was introduced when the VHF frequency band at 169 megahertz was freed for as a license-free band. It also allows higher output power, up to 500 milliwatts. So this gives us a very long range, also because of the low frequency. The 169 megahertz gives very good penetrations into buildings. And this has really been a challenge for gas meters and water meters, which are typically installed in basements or down in pits out in the street. So very difficult RF environments. But with the N mode, we have seen that we can get very good coverage even in dense urban areas using the VHF frequency. Yeah, and as I mentioned, the frame format B can be used for modes C and N as an alternative to make the radio frame itself even more compact and therefore shorter transmissions, eventually saving battery power. So what about the modes and how they are used? Well, I guess still the T mode is probably the most used mode, based on the 100 kilobits per second, giving fairly short transmissions. But the mode C is getting more and more popular as the receivers and the gateways also start to support the C mode. Yeah, and a typical use case for the C mode is drive-by applications. We have seen systems where the garbage truck is receiving metering data while driving through the streets. And both the T mode and the C mode are used for indoor networks, where you have one concentrator or a gateway talking to a few meters. And it could even be the electricity meter that is working as a gateway for gas meters, water, heat, and displays. So the C mode require a little bit more sophisticated receiver, but it's also possible to make a dual mode receiver. So that means receiving either T or C mode with the same receiver, and that's something we have done in the RC1180 MBUS 3 module. The mode N was developed for larger coverage and longer range. So the typical you can cover 1 to 2 kilometers even in urban areas. And as I mentioned, very good for difficult radio environments. And this is due to the lower frequency, the 169 megahertz, which tends to sneak around corners and also get into to pits and into basements. And again, the narrowband radio, the 12.5 kilohertz channels, gives us very good sensitivity, and it also gives us very good selectivity, so reducing any disturbance from other radio transmitters. Okay, so we can do a comparison based on the link budget. So here we have listed the different modes in the different frequency bands, and compared the link budget given the maximum output power that is allowed in that band, and also the typical sensitivity as it's specified in the standard. Of course, the actual sensitivity will depend on the implementation. But using the numbers from the standard, and also taking into account that the antenna and the antenna size can be a limiting factor, especially at 169 megahertz, where the wavelength is quite long, we usually have to use a shorter than optimal antenna. So in this calculation, we have shown that the 169 probably have a loss in the antenna of minus 7 dB, and even for 433 megahertz, we might have a loss of minus 3 dB. So I highlighted here the T mode and the C mode, and also the two N mode data rates. And we see that the T mode and the C mode is not that different. The main difference between them is that the C mode offer even shorter transmissions, and therefore saving battery power. But in terms of range, there is not really a big difference. However, the big difference is between these modes and the narrowband mode. So if you really have a challenge with the range, then you should look into the N mode. Okay, the standard is kind of built up in different layers, as in the OSI model. First, a quick look on the medium axis and the link layer. I already mentioned the two frame formats, where the B is a bit more compact. The link layer use some CRC check to detect any frame errors, but it cannot correct them. The medium axis works in a way that, well, if it's a one-way communication, then the meter simply wakes up, it shouts, it do the transmission, and then it goes back to sleep. If it's a two-way communication, then after doing the transmission, it will go into listen mode, but for a very, very short time. And this is in order to save battery power before it will eventually go back to sleep. So this short listening window is the key to the very low power consumption, even for two-way communication. But of course, this is a limitation when it comes to the response time. You cannot simply talk to a meter when you like to. The meter has to wake up and do a transmission first. On the link layer, the protocol is determined by what is known as a C field. So this will define the type of message. If it's a so-called send no reply message, that's what's usually used for a transmission, or if it's a command back to the meter, which is a send user data message, or it could be an acknowledge, etc. The link layer also contains a unique address, 8 bytes, and 2 of these bytes are dedicated for a manufacturer ID. So if a manufacturer use the 6 remaining bytes as serial numbers, this will ensure that there are only unique addresses used. Okay, if we go to the next layer, that's a transport layer offering us the security. So Wireless MBus now offers services for integrity, authenticity, confidentiality of the data, and also protection against playback. And this is then done by the transport layer, which defines which security mode to use. We will look into the different modes later on. And also we have a supporting layer called the authentication and fragmentation layer. So obviously used for authentication, but also used for fragmenting messages. That means if a message is too long to be transmitted in one single packet, it has to be split up, and that is known as fragmentation. The encryption used is based on AES, the encryption standard, using 128-bit keys. And several submodes of AES are used, like the CBC and the CTR. For authentication, we are adding what is known as a MAC, a message authentication code, or a hashtag. So this could be, say, 2 or 4, maybe 8 bytes, which is unique for the content of the message. The specific algorithms used are the CMAC or the GMAC. Also, there is a key derivation function specified, and this is used to make sure that we never use the same key twice. So, of course, this is to make an even better protection against hacking. Message counters are also used to make unique initialization vectors for the encryption algorithm, and also to generate these unique keys. So every new message has a new counter value. Then we have all the different security modes using combinations of these tools. So these security modes are numbered 5, 7, 8, 9, etc. Here is a table giving you an overview of that. So these are the modes now specified in the new part 7 of the standard. I would like to point out mode 5, which is kind of a simple mode. It's offering confidentiality, so that means it uses encryption. So this can be used as like a first step, protecting the data from anybody else to understand it. To take it to the next level and add authentication, then you have the mode 7. And these two modes are also coming from OMS. In addition, OMS defined mode 13, and this is using TLS. TLS is the transport layer security, also used in the internet. And this was a result of some requirements, some national requirements in Germany, coming from the security office in Germany, the BSI. Okay, jumping upwards in the layer stack, we come to the application layer. And actually, you can use different application layers on top of wireless MBus. So not only the MBus application layer, but you could, for example, use DLMS COSAM, SML, or you could even use a manufacturer-specific application layer that you define yourself. But using the MBus standard application layer, you will use what is known as the diff and the vif. These are descriptors. So they will, for example, describe that the data in this message is volumes in liters expressed with a certain number of digits. And also a part of the address, you have the device type, which tells us if this is a water meter or a gas meter, or even if it's some kind of a sensor, temperature sensor, humidity sensor, etc. So this is the standardized way to code data in the application layer. And not only one data point can be sent in one message, but you can add several of them. Then I will jump to some of what we can call the dialects of wireless MBus, or system specification based on wireless MBus. And the first one is OMS, which was a German initiative, but there are participants from all over Europe. And as we have seen, it also specifies frequencies for using OMS outside Europe. And the purpose is to ensure interoperability by using wireless MBus, by narrowing down a bit which modes, etc., and how to use it. The latest specification is the generation 4. So I will say a few words about what's new in generation 4. First of all, it's these security modes, which we already touched. It was the definition of the authentication and fragmentation layer. Also, security mode 7, which was adding the authentication. And then the security mode 13 for TLS. And that's what making it BSI compliance. So the TLS is required in Germany for all two-way communication of metering data. It also added the use of the extended link layer. So this is to add more information used by security and also for two-way communication, and also to support repeaters. The C mode was also added to OMS as a new physical layer and MAC layer. And there is also a security management protocol related to the TLS that was added. Again, security was an important aspect of the update to generation 4. So here are some more details on that. There are different profiles defined, security profile A, B, and C, depending on the use case. So as I mentioned, profile C with the TLS must be used for the two-way communication in Germany. But in most cases, profile A or profile B will be sufficient. So I will leave it to you to study the details on this slide. Okay, jumping over to Italy and the SHIG. They also made a companion standard, the TS 11291. And this was made for the gas metering system rollout in Italy. It is based on the 169 megahertz N mode, but it did some additional requirements, especially to the physical layer and also to the medium access. So first of all, it adds output power control. So the purpose of this is to be able to dynamically change the output power from each meter or from each transmitter, so that you can reduce the power if you are close to a concentrator, and you can increase it if you are further from it. And of course, this is to reduce the overall radio interference in an area when you have a lot of meters. So typically, concentrator at 169 megahertz would probably receive more than 1,000 meters in an urban environment. So that's why it's important to reduce the output power. It also introduced listen before talk, again to reduce the number of collisions on the air, and also set stronger requirements to the receiver side. So the receiver should be according to category 1, which is defined in one of the radio standards, the EN 300-220. And yeah, just mentioning that the Radiocrafts module RC1701HP can be configured to meet these specific Italian requirements as well. Then we leave Italy and we go to France. The WISE Alliance was founded in France last year and is based on the gas metering deployment done by GRDF. Also based on N mode and 169 megahertz. And it's intended not only for metering, but also for more general smart city applications. So this is like an LP WAN with 169 megahertz base stations. There are some modifications to the protocol. On the link layer, it's some different use of the C field and the addressing. It also specifies how to do firmware upgrade over the air. It provides a new transport layer and application layer. So far it has been defined for gas metering and water metering. And it also specified how to do the installation using some ping pong sequences to test the actual link, and also how to remove a device from the network. And it also specifies how to do command response. So for example, reading a special parameter out of a device. It also adds some security features using AES encryption and CMAC authentication. And the WISE dialect of wireless M-Bus will be supported in an upcoming product from Radiocrafts, known as the RC1701HP WISE. Okay, let's look at some advantages and disadvantages of wireless M-Bus. So about advantages, first of all, it's a standard, and it has been developed by experts in the industry. It's well proven. It's a toolbox to choose from depending on the use case. It's made for very low power, designed for battery operated meters, can be used for any kind of battery operated sensor. It has a very compact protocol, it's very little overhead. So a typical message is only 20 to say 50 bytes. And you can make devices of 15 years of battery lifetime or more. It's a quite simple protocol intended for data collection. So it's a bubble up. The devices are transmitting without any acknowledge, making it very simple. But it also offers two-way communication. Of course, there is a latency because there has to be a transmission from the device first. And I would also say that the 169 megahertz opens up new applications because of the very long range. So it's a very good alternative to other low power WAN technologies. Further, security has become more and more important, and you have a rich set of tools within wireless M-Bus, encryption and authentication. And also as an advantage, we can mention that there are radio modules available integrating the whole complete transceiver and the protocol into a small compact device. And examples of these are the RC1180 M-Bus 3 and the 1701 HP M-Bus 4. And of course, this reduces the development cost and shorten the time to market and lowering the risk because these are proven solutions. Some of the disadvantages, well, it's a standard, but again, it's many choices. So maybe that could prevent the interoperation between different implementations. So this means it has to be a well-defined subset of options when you make a system specification. Unfortunately, there is not one global solution because of the different frequency regulations around the world. But you can do a combination of, say, 433 megahertz and 868 megahertz, and you will cover most of the world, still using one common protocol in the upper layers. And if you add in 915, you could also cover the US. Well, the data rate is pretty low, so of course it's not suitable for applications requiring data streaming or transferring images or similar. This is for more for sensor data. In the standard, there is no listen before talk or retransmissions, so it depends on a bubble up and frequent transmissions. So usually you rather do more transmissions than you actually need to ensure that you at least will receive one of them and get the updates. Another drawback is, of course, that 169 megahertz is not available outside Europe. Then a quick summary on which frequency and mode should we then use? Well, again, it depends on the market and the geography because of the frequency regulations. 869 and 169 megahertz can be used in Europe. 433 outside Europe. 865 in India. And 865 in the special subband in Russia. And then you should look into the use case. If it's a drive-by, for example, or you need to do very frequent transmissions, then you probably should look into mode T or mode C because of the higher data rate and shorter transmissions. Also, if it's in-house or you're covering just a small neighborhood area, you might look into the S mode or T or C mode. If you have installations, say some sensors or meters down in basement, pits and so on, like the water and gas meters, then look into the narrowband mode N, because that gives you definitely the best range and best penetrations into buildings and also in urban areas. So, and the systems using 169 megahertz typically have the base stations located at the elevated points, like on rooftops or in some towers. Okay, we are soon getting to the end. I just wanted to tell you something about how Radiocrafts can help you to get started using the wireless M-Bus and get it into your products. So we offer radio modules acting like modems. These are the M-Bus 3 and the M-Bus 4. You have a UART interface. You can configure the module, and you can do full two-way communication with your device. And it includes the error checks and the encryption and decryption, etc. So this is a very easy way to get started using the M-Bus standard. We also offer some autonomous pulse counter modules. So this means that the pulse outputs from water meters or gas meters or any other type of pulse generator can be connected to the module. These pulses are counted and radio transmissions are scheduled. It will add the necessary security, encryption, authentication. It can also offer you further download over the air, and even some local configuration interface, which could be over radio or over NFC or optical interface. A new option that we are introducing these days is modules with configurable sensor interfaces, the MSM. So instead of a pulse input, we can actually interface directly temperature sensors, humidity sensors, gas sensors, etc. So any type of sensors that can be hooked up through an I2C bus or an SPI or a general I/O pin. And again, it's configurable transmission intervals with thresholds, etc. So please pay attention, and you will soon get more information on this new product series. Finally, we are also assisting customers doing application and custom-specific designs. So these can be compact designs where we do all the electronics with the power management, the battery, integrating the antenna, which sometimes can be a challenge, definitely at 169 megahertz, and ensuring to have the highest possible radiated power from the module, and at the same time having battery lifetimes of more than 15 years. So we already did several designs doing clip-ons for mechanical water meters. So here is an example of our wireless M-Bus module with the compact and the complete wireless M-Bus stack embedded. Small compact module, 12 by 25 millimeters. Comes in different variants for the different frequency bands. Yeah, and delivered on tape and reel, conform to the red directive with the DOC. So that takes me almost to the end of the presentation, just giving you some of the references used to make this presentation. So here you can see the wireless M-Bus standard, reference to the OMS specification, the Italian companion standard, and also the WISE Alliance specification. So you can look into those. You can also go to our web page, and there you find product data sheets, you find application notes, white papers, and you can search over knowledge base. I think I used my time and a little bit more, so with this, I will hand it back to you, Anders, because I think you will say something about the development kit.
Yes, thanks a lot, Peder Martin. Good and interesting presentation as always. So yeah, we are heading into the Q&A session now. So any questions you might have, please put those in the chat window, and we will respond to them in real time as much as we can. If we don't have the time, then we will gather those and respond as well, as I mentioned in the beginning. The wireless MBUS development kit, as Peder mentioned, the offer there, you will find that on your right-hand side in the chat window, how to get access to this. It's the fastest way to get started with the wireless MBUS series. So with that, let's go to the Q&A session and see if there's anything in the chat window. While we do that, let me just see, because there was something that came to my mind here when we were talking, or when Peder was talking. I think so. Some of them are of general interest, and one of the things is really, what is the range? I think with 169, you said it's a long range. Do you have any specifics on that, Peder Martin?
I think we lost Anders, or are you still here?
I'm here, but I hope you can hear me.
Yeah, no, I can hear you also.
Oh, okay. Yeah, so sorry if you lost me there for a little bit. I was just looking into the Q&A session here. I think we have the first question coming in here that I can read out, is just a question on where we are in terms of products and use cases for the 915 for the United States. That's a question from Rob Roy.
Yeah, I can answer that quickly. So 915 megahertz is still not a part of the standard, neither the EN standard or the OMS extension of frequency bands, but there has been implemented some proprietary solutions, and that's what we have also done, supporting some meters that are using 915 and also 921. So please get in direct contact with us, and we can help you out there.
Okay, thanks a lot. I have a next kind of a comment more, but I think maybe if you can help to expand on that, Peder Martin, is it's Prasad who says he's using the 1140 MBUS3 for the Middle East. So I guess the comment that could be of interest is, what do you have any view on 433 megahertz wireless MBUS for the Middle East and also for other countries, if you can comment on that?
First comment would be that you're not the only one using 433 for the Middle East. So that is now being used in several Middle Eastern countries. And not only there, but we also see it in, I believe, in Australia. You can use the 433, and also in South America and specifically Brazil. I can now see you comment that you're in India. And to my knowledge, you're not allowed to use 433 megahertz in India, but the option for you would then be the 865 megahertz variant. That's covered by our product 1170 MBUS 3.
Okay, thank you. We have a very local question to you, Peder Martin. It's Matthias. He asks, have you looked into any good solution to the new Norwegian HAN interface in the new electrical meters?
The short answer would be no. But yes, wireless MBUS would also be suitable for these kind of HAN interfaces. But it's not something we have looked into in detail.
Okay. Those were the questions coming in on the chat for now. I had another one where I think could be of general interest here is the range of 169. I know we've done some tests on how long the actual range is on 169. Can you give us a few words on that, Peder Martin?
Yeah, maybe I could first refer to some tests done in France, actually, which was kind of the start of what ended with WISE and WISE Alliance in the end, because they did a test using the 169 and also 433 and 868 for real deployment of, I think it was 5,000 water meters. And the clear conclusion for that was that 169 gave definitely the best coverage in urban areas. In terms of range, we did a test here in central Oslo, actually from our office building and straight down to the very center, downtown Oslo. That's a range of 3.5 kilometers. And the radio still worked perfectly. So that gives an indication of what you can achieve with 169 megahertz.
Okay, thank you. So I have from Ahmed a question. What solution would you recommend for, or solution as in terms of frequency, mode, and product for the Middle East for gas and water meters? I think we touched on that for the 433. Is there something else we can comment on that?
Yes, in general, I would say use 169 for gas and water meters because of the typical installations, at least here in Europe. But then 169 is not a license-free band in the Middle East, so the best solution there would then be to use the 433 megahertz solution we just discussed.
Okay. Question coming in from Mark. If I'm right, you said that TLS is mandatory for two-way communications in Germany due to the BSI. Is that right? And if so, does that mean that other security modes for two-way communication in Germany are not allowed?
Yeah, to my knowledge, this is the regulation for utility meters using these data for billing purposes. So this is in order to, say, protect the consumers. So if you have a two-way communication link, say to an electricity meter, reading the electricity index, then it should be using the two-way communication and TLS. If you're doing a general industrial sensor network with two-way communication, then, to my knowledge, you don't have to follow the BSI regulations.
Okay, thank you, Peder Martin.
Yeah, hope that covers your question, Mark.
Okay, quick question from Thomas. Is 169 megahertz usable in the United Kingdom?
That's actually a very good question. That I would have to check because the use of 169 megahertz in Europe has been expanded, say, country by country. And if 169 is not available, there are some other close frequency bands that could be used. But the reference to check here is the SEPT document 7003. And there you can look at the different national implementations of the 169 megahertz band.
So the name is SEPT 7003, is that correct?
Yeah, the document is coming from SEPT, and it's the, I think it's called the ERC 7003.
Okay.
If you still don't find an answer to that, Thomas, please contact us and we will help you to clarify it.
Okay, thank you. I think we're getting here time to the hour, so we'll have one final question and then we will stay on the chat window for a little bit, but this will be the last question that we'll take in real time here on audio. So this is from Christoph. Could you tell me what is specified in NTA 8130 standards, which is sometimes mentioned in the OMS? Is it talking about applications or some other layer?
Yeah, the NTA 8130 was a national standard for the Netherlands. But this was already some time ago. So yes, they originally defined some special security modes. The mode 4 were used in the Netherlands, and also some other deviations, say, from the OMS. But since then, they have come up with some new standards. So I would say the NTA 8130 does not apply really anymore in the Netherlands. Well, so it's a reference to an old specification from the Netherlands.
Okay, thanks a lot. So with that, I would like to thank all our listeners to the webinar, the participants on the chat window, which I always find very encouraging, and of course Nereus running the show in the background, and last but not least, I should say, Peder Martin, thanks a lot for a very good presentation, useful. For all, we will make this webinar available on our website in the next couple of days or week. So if you want to look at it again, listen to it again, please feel free to download it. You can also share it with your friends and colleagues. So with that from me, Anders, thanks a lot. Peder, any final word from you before we close the show?
Again, thank you all, and we hope to stay in touch with you.
Okay, thanks a lot, and have a good day, and wish you all the best in Wireless Emba's future going forward.